Everything you see, touch, breathe, fear, or love follows one ruthless rule. One invisible command that shapes the fall of a stone, the arc of a planet, the flicker of light in your eyes, and the atoms holding your body together. You wake up inside it. You move inside it. You think inside it. And most of the time, you don't even realize it as there. You were taught that physics is complicated, that it is a jungle of formulas, symbols, strange diagrams, and endless laws to memorize. You were told that motion is one chapter, electricity another, light something else, and quantum mechanics a completely different beast. So you built walls in your mind. You separated everything. You accepted confusion as normal. But here is the uncomfortable truth. Reality is not fragmented. Your understanding is. There is a single, powerful idea that runs beneath almost every equation you've ever seen. It is not flashy. It is not dramatic. It does shout. It quietly governs everything with brutal consistency. From the smallest quantum fluctuation to the motion of entire galaxies, this idea does not bend, does not hesitate, does not negotiate. And once you truly grasp it, physics stops looking like a collection of random rules. It becomes a single story told in different accents. Look around you. Every object in your room is sitting where it is because of energy relationships. Every movement you make follows invisible constraints. The air in your lungs, the warmth in your skin, the light reaching your eyes. None of it is accidental. None of it is chaotic in the way you casually imagine chaos. Beneath the surface noise, there is structure. Beneath the structure, there is optimization. That word might disturb you, optimization, because it suggests something precise, something calculated, something almost intelligent though not conscious in the way you think. The universe does not guess. It does not experiment randomly. It follows a principle so strict that entire branches of physics can be rebuilt from it alone. And here is the shocking realization. Most of what you struggle with in physics is not difficult because the universe is complicated. It is difficult because you were never shown the spine that holds everything together. Instead, you were handed pieces, forces here, energy there, momentum somewhere else. Disconnected tools without the blueprint, so you memorized. You solved problems mechanically. You survived exams. But deep down, it felt heavy. It felt like juggling too many rules at once. That heaviness is not the fault of reality. It is the result of learning effects without understanding causes. There is a deeper layer, a quieter layer, a layer where motion is not about pushes and pulls but about paths, where light is not simply rays bouncing around, but a system obeying a deeper condition, where particles do not just move, they explore possibilities, and the universe selects, not emotionally, not morally, not randomly, systematically. It chooses the path that satisfies a single mathematical demand. This is where your perspective must shift, because once you see that physics is about selecting optimal paths, not memorizing scattered laws, everything rearranges itself in your mind. The confusion starts collapsing. Patterns start emerging. Equations that once felt unrelated begin to echo the same structure. This is not poetic exaggeration. It is structural reality. Planets orbit not because they prefer circles, but because their motion satisfies a deeper balance. Light bends not because it decides to change direction, but because its path must obey an optimization condition. Even at the quantum level, where certainty dissolves and probabilities dominate, the same underlying logic remains refined, expanded, but not abandoned. That consistency should shake you, because it means the universe is not patched together. It is coherent. And if reality itself is coherent, then your approach to understanding it must also become coherent. You cannot keep thinking in fragments. You cannot treat each chapter as a separate island. If you do, physics will always feel overwhelming. It will feel like an endless list of rules with no central anchor. But once you recognize that there is one guiding principle, one idea powerful enough to derive motion, fields, waves, and even quantum behavior, your mindset changes. You stop chasing formulas. You start searching for structure. And that shift is everything. Because this is not just about physics. It is about how you think. If you train your mind to look for underlying principles instead of surface complexity, you develop clarity. You develop depth. You stop being intimidated by appearances. The universe is not trying to confuse you. It is operating with ruthless simplicity at its core. The question is whether you are willing to look past the noise and see it, because once you do, there is no going back. Here it is, stripped of decoration and mystery, The universe always follows the path that makes the action stationary, and in most cases minimal. That is the backbone. That is the silent rule running beneath motion, light, fields, and even the strange behavior of quantum particles. Action is not a casual word here. It has a precise meaning. It is a quantity defined by energy evolving over time. More specifically, it is built from something called the Lagrangian, the difference between kinetic energy and potential energy, integrated across time along a path. In simple terms, action measures how a system spends its energy as it moves from one state to another. And here is the key. Out of all the imaginable paths a system could take between 2 points in time, the one actually observed in reality is the one that makes this action stationary. Not wildly fluctuating, not arbitrary. Stationary, usually minimal. Pause and think about what that implies. When a ball travels through the air, it could, in theory, take infinitely many curved trajectories between its starting point and where it lands. Most of those paths are mathematically possible. Yet only one trajectory actually occurs. That trajectory is not chosen because it is the shortest in space. It is not chosen because it looks right. It is chosen because among all possibilities, it satisfies this deep optimization condition on action. This is not a superficial rule layered on top of physics. It generates the laws of motion themselves. Take classical mechanics. The equations that describe acceleration, momentum, and force are not fundamental starting points. They fall out naturally when the action is minimized. If the action is written correctly for a system, and the condition of stationary action is applied, the familiar equations of motion appear automatically. They are consequences, not assumptions. That is a reversal of how most minds were trained. Instead of starting with forces and building upward, this principle starts with a global condition on the entire path through time and derives forces from it. It does not look at one instant in isolation. It evaluates the whole journey at once. The path is selected as a complete entity constrained by the demand that the action cannot be slightly varied without increasing or altering its value. This is a profoundly different way of thinking. It means motion is not merely about what is happening now. It is about the consistency of the entire trajectory between past and future. The system behaves as if it knows the boundary conditions and adjusts accordingly. Not through foresight, but through the mathematical structure that governs reality. Consider light traveling between 2 points. It does not wander randomly. It follows the path that makes the travel time stationary. In uniform media, that becomes the shortest path, a straight line. In varying media, it bends in exactly the way required to satisfy the condition. This is not coincidence. It is optimization expressed through geometry. Now, go deeper. In electromagnetism, the behavior of electric and magnetic fields can also be derived from a properly constructed action. The equations that describe how fields propagate and interact with charges emerge from the same stationary principle. The language changes. The symbols become more abstract. But the backbone remains untouched. Then comes quantum mechanics, where reality appears probabilistic and strange. Even here, the idea survives. Every possible path between 2 points contributes to a particle as behavior, but the paths near the stationary action dominate through constructive interference. The classical path, the one of least action, emerges as the most stable contribution in the limit where quantum effects become small. The principle does not break under pressure. It expands, and that expansion is a shocking realization. What looks like a patchwork of unrelated theories is actually different expressions of the same structural demand. The action must be stationary. This forces a brutal conclusion. Physics is not fundamentally about forces pushing objects around. Forces are a convenient interpretation. At a deeper level, reality is governed by variational principles. It is governed by global optimization across time. That shift in perspective matters, because it replaces local thinking with holistic thinking. Instead of asking what happens at a single moment, the principle evaluates entire histories. Instead of piecing together events step by step, it imposes a condition on the full arc of motion, and it does so with mathematical precision. The action is calculated for a path, then the path is varied slightly. If the action changes to first order, that path is not realized. The true path is the one where small variations do not change the action at first order. That requirement produces differential equations, the equations of motion as necessary conditions. Nothing mystical, nothing decorative, just structure. This is why the principle is so powerful. It does not merely describe motion, it generates it. It does not sit alongside other laws. It contains them. When understood properly, it becomes clear that the diversity of physical phenomena, falling bodies, orbiting planets, oscillating springs, propagating waves, are not separate stories. They are different expressions of one optimization rule applied to different energy configurations. That unity is not obvious at first glance. It requires stepping back from memorized formulas and seeing the architecture beneath them. But once seen, it becomes difficult to unsee. The universe does not stumble into behavior. It does not improvise laws on the fly. It follows a strict demand among all conceivable histories connecting two states. The realized history is the one that makes the action stationary. One idea, relentlessly applied, and from it, almost all of physics unfolds. Action is not effort. It is not how hard something tries. It is not intensity, struggle, or visible movement. It is a precise mathematical quantity, and misunderstanding it is the fastest way to miss the depth of this entire idea. At its core, action is built from energy and time, not one, both. It measures how energy is distributed across the duration of a system as evolution. More specifically, action is defined as the integral over time of a quantity called the Lagrangian. And the Lagrangian, in many familiar systems, is the difference between kinetic energy and potential energy. That difference matters. Kinetic energy represents motion. Potential energy represents stored configuration, position within a field, height in gravity, tension in a spring. When a system moves, these energies continuously exchange. Motion increases kinetic energy. Height increases potential energy. The Lagrangian tracks the balance between them at every instant. Action accumulates that balance over time. Imagine every possible path a system could take between two fixed points in time. Each path carries a different history of kinetic and potential energy. Some paths require high speed early on and slow down later. Others move gently but take longer. Some wander unnecessarily, others curve sharply. For each imaginable path, the action can be calculated by integrating the Lagrangian across the full time interval. Most of those paths produce wildly different action values. But one path, the one nature actually realizes, makes the action stationary. Stationary does not always mean the absolute smallest possible value. It means that if the path is nudged slightly, the action does not change to first order. Small variations around that path do not lower the action. That condition, when translated mathematically, produces the Euler-Lagrange equations, and those equations are equivalent to the familiar laws of motion. This is where the shift becomes profound. Instead of thinking that forces directly cause acceleration as a starting axiom, acceleration emerges from the requirement that the action be stationary. The laws are not imposed from outside. They are consequences of an optimization condition applied to the entire trajectory. Time plays a critical role here. Action is not about a single moment. It is about the full history between an initial and final state. The system, as path, is treated as a continuous curve through time. Every tiny segment contributes to the total action. The chosen path is the one where the cumulative balance of kinetic minus potential energy over time satisfies the stationary condition. That means motion is determined not by isolated snapshots, but by consistency across the whole interval. This idea feels counterintuitive at first. It almost sounds as if the system knows where it will end up, but nothing mystical is happening. The boundary conditions, the starting and ending points in time, define the allowed set of paths. Within that set, the stationary action condition filters out all but one physically realized path. The mathematics does the selecting. Consider a simple example, a particle moving freely with no forces acting on it. The potential energy is constant. The Lagrangian reduces essentially to kinetic energy. If all possible paths between 2 points in space and time are examined, the straight-line path with constant velocity makes the action stationary. Any deviation, any unnecessary curve or speed change increases the action. So the particle moves in a straight line. Now introduce gravity. The potential energy depends on height. The Lagrangian changes accordingly. Recalculate the action for all possible paths. The stationary condition now produces a parabolic trajectory, the familiar arc of a projectile. Not because gravity commands it to curve, but because the path that balances kinetic and potential energy over time in the stationary way turns out to be a parabola. Change the energy structure, and the path changes. But the rule does not. This is why the concept of action is so powerful. It is flexible enough to describe wildly different systems, yet strict enough to generate precise equations. It does not care whether the system is a swinging pendulum, an orbiting planet, or a vibrating string. As long as the correct Lagrangian is written down, the stationary action principle produces the equations governing motion. Energy and time are inseparable in this formulation. A path that minimizes energy but takes too long may not minimize action. A path that is extremely fast but requires enormous kinetic energy also fails. The realized path balances both. It is not about being shortest in distance. It is not about being lowest in energy at every moment. It is about the integrated trade-off across time. That trade-off is subtle. It explains why nature often takes paths that seem indirect. Light bends when entering a new medium, because the straight-line route would not minimize travel time. A mechanical system oscillates, because remaining fixed at a displaced position would not satisfy the stationary action condition across time. Even stable equilibrium configurations correspond to states where small variations do not reduce action. Once understood, action becomes more than a definition, it becomes a lens. Instead of analyzing forces step by step, entire motions can be examined as unified wholes. Instead of focusing on local pushes and pulls, the global structure of a path takes priority. This approach scales upward into advanced physics. In field theory, the action is defined not just over particle trajectories but over fields spread across space and time. The same stationary principle yields Maxwell's equations for electromagnetism and Einstein's field equations in general relativity when applied with appropriate Lagrangians. The objects change. The rule does not. Action, then, is not an abstract mathematical trick. It is the organizing quantity that compresses vast physical diversity into a single demand. The realized history must make the action stationary. Energy minus potential, integrated over time, filtered by variation. From that, motion emerges. And once this is internalized, physics stops being a list of disconnected laws. It becomes a disciplined consequence of one definition carried to its logical conclusion. You were taught to think of nature as dramatic, collisions, explosions, forces pulling and pushing in constant battle. The language of physics often reinforces that illusion. Strong force, weak force, attraction, repulsion. It sounds like conflict, it sounds emotional. But beneath that vocabulary, there is no drama at all. There is efficiency. Reality does not waste motion. It does not wander aimlessly. It does not experiment with chaotic alternatives before settling on one. It obeys a strict demand: the action must be stationary, and that requirement strips away the theatrical narrative of forces wrestling objects into submission. A planet orbiting a star looks like a delicate dance between gravitational pull and inertia. That is how it is usually described, but at a deeper level, the orbit is simply the trajectory that satisfies the stationary action condition for a gravitational Lagrangian. Among infinitely many imaginable curves through space and time, one path balances kinetic and potential energy in precisely the required way. That path is realized. The rest are mathematically possible but physically discarded. There is no struggle in that selection. Only consistency. Light bending as it passes through glass seems like a change of direction caused by entering a new material. The explanation often focuses on refraction indices and wave speeds, but the deeper layer is the same principle. The path taken between 2 points makes the travel time stationary. In uniform space, that becomes a straight line. In varying media, it becomes a curve. The bending is not a reaction. It is an optimization. Even at the level of a falling object, the story is often simplified into force equals mass times acceleration. Gravity pulls downward, acceleration follows. But that familiar equation can be derived entirely from the stationary action principle. The object follows the path through spacetime that balances its kinetic energy and gravitational potential energy over the duration of its fall. The force description works. It predicts correctly. But it is not fundamental. Forces are summaries. They are the surface language of a deeper structure. This is where the brutal shift happens. If forces are not fundamental, then the way motion is commonly imagined, as constant pushing and pulling, is incomplete. At the core, the universe is not driven by active pushes. It is constrained by variational conditions. It does not try to accelerate objects. It filters possible histories through a mathematical demand. That filtering creates what appear to be forces. Consider equilibrium. A ball resting at the bottom of a bowl remains still. The usual explanation says gravitational force pulls it down, while the normal force pushes it up, balancing perfectly. But from the perspective of action, the equilibrium position corresponds to a configuration where small variations do not lower the action. Any slight displacement increases the action, so the system remains at that stationary point. The language changes. The interpretation deepens. Or consider oscillation. A pendulum swings back and forth with precise timing. It seems as though gravity pulls it down while tension redirects its motion, producing periodic movement. Yet the oscillatory motion is simply the stationary action path between successive moments, constrained by energy exchange between kinetic and potential forms. The repeated motion is not forced into existence. It is selected as the consistent solution under the variational rule. Efficiency does not mean minimal movement. It means balanced movement. Sometimes the stationary action path looks simple. Sometimes it looks complex. What never changes is the rule that determines it. This is the uncomfortable realization. Nature is not chaotic at its foundation. It is optimized. The complexity observed is layered on top of a principle that is mathematically precise and structurally unified. Even quantum mechanics, often described as random and unpredictable, respects this backbone. A particle does not follow one single classical path in the microscopic realm. Instead, every possible path contributes to its behavior. But paths near the stationary action reinforce each other, while wildly different paths cancel out through interference. The classical trajectory emerges as the dominant contribution when quantum effects become small. The principle does not disappear in the quantum world, it becomes more subtle. Efficiency remains, and that consistency should reshape the way reality is viewed. Instead of imagining a universe driven by mechanical pushes, picture a universe constrained by global conditions. Instead of seeing motion as reaction, see it as selection among possibilities. This perspective eliminates unnecessary mysticism. It removes anthropomorphic language. Planets are not held in orbit by dramatic pulls. They follow trajectories that satisfy a stationary condition across time. Light is not confused at boundaries between materials. It obeys a travel time optimization rule. There is no hesitation, no indecision, only lawful structure. This also exposes a harsh truth about human intuition. Intuition is built on everyday experience. Push something, it moves. Let go, it stops. The force narrative feels natural because it aligns with direct perception. But intuition does not penetrate to the foundational layer. It describes appearances, not architecture. The architecture is variational. That word carries weight. It means that nature evaluates alternatives. Not consciously, but structurally. The equations governing reality emerge from requiring that certain integrals over time do not change under small variations of the path. This is colder than the usual story, less emotional, more precise, and far more powerful. Because once efficiency replaces drama in the mental model, the scattered rules of physics begin to collapse into unity. Motion, light, fields, and even space-time curvature are no longer separate phenomena. They are different manifestations of the same optimization demand expressed through different energy structures. The universe is not performing chaotic theater. It is solving equations. Here is the first harsh truth. What is often labeled as complicated physics is usually the repetition of one principle wearing different mathematical clothing. The symbols change. The notation becomes heavier. The systems grow more elaborate. But beneath the surface, the same structural demand keeps reappearing. The action must be stationary. Most learners never notice this because they are trained to focus on outcomes, not origin. They are handed Newton's laws as starting points, then Maxwell's equations appear in another chapter, then the Schrödinger equation. Each theory feels isolated, like a new mountain to climb from scratch. The impression is that physics is a growing list of unrelated discoveries. That impression is misleading. Newtonian mechanics can be derived entirely from the stationary action principle, using a simple Lagrangian built from kinetic and potential energy. Electromagnetism emerges from a different Lagrangian constructed from electric and magnetic fields. Quantum mechanics can be framed through a path integral formulation where action plays the central role. The underlying structure is not replaced, it is reused. The second harsh truth is even more unsettling. Forces are not fundamental ingredients of reality. They are byproducts. They are mathematical artifacts that appear when the stationary action condition is rewritten in a local form. The deeper layer is not about pushes and pulls. It is about constraints on entire histories. This means the usual story. That gravity pulls, electricity attracts, magnetism repels is an interpretation. It works for calculation. It builds intuition. But it is not the bedrock. The bedrock is variational. The discomfort comes from realizing how much mental energy has been invested in memorizing formulas without seeing this unifying pattern. Hours spent solving isolated problems. Pages filled with derivative steps. Exams passed through repetition. Yet the central spine remained invisible. That invisibility creates fragmentation. Fragmentation creates confusion. And confusion leads to the belief that physics is inherently chaotic. The third harsh truth follows directly. If foundational principles are ignored, understanding becomes shallow. It becomes reactive rather than structural. Problems are approached as puzzles requiring specific tricks instead of expressions of a deeper rule. Without the unifying idea, every new equation feels like an exception. With it, equations become inevitable. Consider how different classical mechanics and quantum mechanics appear at first glance. One describes predictable trajectories. The other speaks in probabilities and wave functions. The conceptual gap feels enormous. Yet when examined through the lens of action, continuity emerges. In quantum theory, every possible path contributes to a particle's behavior. But paths near the stationary action dominate through constructive interference. The classical path arises naturally as a limiting case. What looked like contradiction becomes continuity. This is not a minor technical detail. It is a structural bridge between entire frameworks of physics. The realization should be jarring. The apparent complexity of physical law is often a reflection of how it is taught, not how it is built. Layers are introduced without revealing the foundation. Tools are distributed without showing the workshop. That is why so many minds feel overwhelmed. They are collecting branches without ever seeing the trunk. When the trunk is finally visible, the forest reorganizes itself. Mechanics is no longer separate from optics at a fundamental level. Electromagnetism is not an isolated miracle. Quantum behavior is not an alien intrusion into classical order. All are different arenas in which the same principle operates. Action is defined appropriately for each system. The stationary condition is applied. The resulting equations govern behavior. Different Lagrangians, same rule. This repetition is not coincidence. It signals depth. In advanced physics, symmetries of the action lead directly to conservation laws. Time translation symmetry produces conservation of energy. Spatial translation symmetry yields conservation of momentum. Rotational symmetry gives conservation of angular momentum. These are not arbitrary coincidences. They are consequences of structural properties of the action itself. The implications stretch even further. In general relativity, spacetime curvature is derived from an action principle involving the geometry of spacetime. The gravitational field equations arise from varying that action. Once again, a new theory emerges from the same backbone. The consistency is relentless, and that relentlessness demands intellectual honesty. The difficulty in physics often lies not in the universe, but in the refusal to seek unification. It is easier to memorize separate rules than to understand a principle capable of generating them all. But memorization decays. Structure endures. The moment this becomes clear, the approach to physics must change. Instead of asking what formula applies to a problem, the deeper question becomes, what is the action of this system? What energy terms define its Lagrangian? What does the stationary condition imply? That shift transforms problem solving into derivation. It transforms confusion into coherence. And it exposes a sobering reality. The elegance of physics was always there. The fragmentation existed only in perception. What seemed like an ocean of unrelated laws is, in truth, a single current flowing through different channels. Ignore that current, and everything feels overwhelming. Recognize it. And complexity begins to collapse into unity. Every equation you have ever memorized, every law you thought stood alone, every chapter you were forced to treat as separate, they are all consequences of the same deep principle. Newton's laws of motion, which describe the paths of falling apples and orbiting planets, do not appear arbitrarily. They emerge naturally from the stationary action principle when the Lagrangian is constructed as kinetic energy minus potential energy. The trajectory of a planet, a ball, or even a spacecraft is not imposed from outside. It is selected by this unyielding structural rule. Among all imaginable paths through space and time, nature realizes the one that balances energy and duration to satisfy the stationary condition. That is the invisible thread running through classical mechanics. Electromagnetism, which often feels like a different language with its fields, potentials, and curls, is no exception. The behavior of electric and magnetic fields can be fully derived from a carefully chosen action. Maxwell's equations, which describe how fields propagate and interact with charges, are not independent axioms. They are consequences of applying the stationary action condition to an appropriate Lagrangian. Charges move, fields oscillate, light propagates, all as outcomes of the same underlying demand. The apparent complexity of the equations masks the simplicity of the principle from which they originate. Move forward to optics. Fermat, as principle. The idea that light takes the path of least time seems like a separate law. It looks intuitive, light chooses the fastest path. But in reality, it is a special case of the stationary action principle applied to electromagnetic energy. The path that minimizes travel time corresponds to the path that makes the action stationary. Refraction, reflection, and even complex lensing phenomena are not exceptions. They are specific expressions of a single, universal rule. Different systems, different appearances, same backbone. Then comes quantum mechanics, often portrayed as a realm of unpredictability, where particles exist in superpositions and outcomes appear random. The classical trajectory seems to disappear entirely. Yet even here, the stationary action principle survives. The path-integral formulation of quantum mechanics considers every conceivable path between 2 points. Each path contributes to the probability amplitude, but paths near the stationary action dominate due to constructive interference, while wildly divergent paths cancel each other out. Classical behavior emerges naturally in the limit of large action relative to Planck as constant. Quantum strangeness does not break the rule, it refines it. The deep structure persists, revealing continuity across scales that seems impossible at first glance. What this continuity exposes is a brutal truth. The diversity of physical phenomena is a surface effect. At first, motion, fields, waves, and particles appear as separate categories with their own rules. Mechanics is here, electromagnetism. There, quantum mechanics, somewhere else. That division is artificial, a product of teaching methods and historical development. At the foundational level, they are unified. The stationary action principle provides the common thread that ties together seemingly unrelated domains. It is the skeleton that supports the flesh of physical law. The implications are profound. It means the universe is not a chaotic patchwork of phenomena. It is a coherent system, and its coherence arises from a single underlying rule. That is why physics works at all, why calculations are precise, why predictions hold, why planets orbit for billions of years without sudden deviation. Nature does not improvise or stumble. It follows the stationary action principle with relentless consistency. Consider the elegance of this unity. In classical mechanics, a particle as motion is derived from a Lagrangian constructed from kinetic and potential energy. In electromagnetism, the Lagrangian involves electric and magnetic fields. In general relativity, the action incorporates spacetime curvature. The symbols, the mathematics, the complexity change, the objects of study change. But the guiding demand remains unaltered, different manifestations. One principle. This is not a coincidence. This is the architecture of reality, speaking in every branch of physics. Recognizing this unity also shifts how problems should be approached. Instead of memorizing formulas and applying them as recipes, the focus becomes, what is the Lagrangian of the system? What energy terms define it? How does the stationary action condition constrain the evolution of the system? This mindset transforms the study of physics from mechanical problem-solving into structural understanding. Every law, every phenomenon becomes a natural consequence of a deeper logic. It also challenges the way intuition has been shaped. Human intuition, built from everyday experience, is local and fragmented. Push something, it moves; release it, it stops. That intuition works for familiar scales, but it does not penetrate the deep, holistic structure of reality. The stationary action principle requires thinking globally across time, integrating energy and motion as continuous histories rather than discrete steps. It demands a perspective that treats entire trajectories as coherent entities. Once internalized, this perspective collapses the perceived complexity of physics. Motion is not isolated from fields. Fields are not separate from waves. Waves are not separate from quantum behavior. They are all expressions of one rule. This realization is shocking to anyone trained in the traditional compartmentalized view of physics. It exposes the artificiality of separating theories and the hidden simplicity behind apparent diversity. This is why the stationary action principle is more than a tool. It is a lens, a framework through which all physical law can be understood. It is the connective tissue between centuries of discoveries linking Newtonian motion, Maxwellian fields, optical phenomena, and quantum mechanics into a coherent whole. Once seen, it is impossible to view reality as a random collection of disconnected rules. Every equation, every law, every phenomenon becomes a consequence of a single structural demand. Different centuries, different discoveries, different notations and frameworks, same backbone. One principle capable of generating the diversity of physics without contradiction. Recognizing this does not just simplify understanding. It changes the way the universe is perceived. It transforms complexity into inevitability. What once seemed chaotic and fragmented now appears ordered and unified. Physics is no longer a list of arbitrary laws to memorize. It is the manifestation of one relentless principle applied across every scale, every system, every trajectory, shaping the behavior of the universe from the tiniest particle to the largest galaxy. You were taught physics as a collection of separate chapters, motion in one section, waves in another, electricity somewhere else, particles, fields, and forces all divided into neat boxes, as if the universe itself obeyed the same arbitrary divisions. The textbooks reinforced this perspective. The chapters, the headings, the isolated problem sets, they all told you to compartmentalize, and that compartmentalization shaped your mind. It trained you to see the universe as fragmented, disconnected, chaotic, but reality does not respect these divisions. Nature does not operate in chapters. Motion, light, electricity, magnetism, even the strange behavior of quantum particles, all follow the same underlying rule. The divisions you learned exist for convenience, not for truth. They are pedagogical scaffolding, meant to simplify teaching, but they distort understanding. At a foundational level, everything is connected, unified, and consistent. Consider motion. In classical mechanics, it seems like a simple story. A force is applied, an object accelerates. Separate that from electromagnetism, where fields propagate and interact. Separate that again from quantum mechanics, where particles exist in superposition. To the untrained mind, these appear unrelated. To the mind attuned to principle, they are expressions of the same structural demand, the stationary action principle. Each law, each phenomenon is a manifestation of a deeper optimization across energy and time. The surface differences are superficial. The skeleton is identical. This is where your perception must shift. Stop seeing physics as disconnected topics. Start seeing it as one coherent architecture expressed in multiple languages. Forces are not fundamental. Equations are not arbitrary. Particles are not independent actors. All emerge from the same organizing rule applied to different systems. Newton's laws, Maxwell's equations, Fermat's principle, quantum path integrals, they are different translations of a single principle. Understanding that changes everything. The implications for learning are profound. When you approach a problem, instead of asking which formula applies or which chapter it belongs to, ask, what defines the energy of the system? How does the path through time behave to satisfy the stationary action condition? Suddenly, problems stop being isolated exercises and start being natural consequences of a deeper logic. The path to solution becomes derivation, not memorization. You begin to predict behavior intuitively by reasoning from principle, not by recalling which equation goes with which scenario. This mindset also exposes a harsh truth. Much of what feels difficult in physics is a result of your own fragmentation. You are not failing because the universe is complicated. You are failing because you are looking at pieces and expecting them to make sense in isolation. You are trained to chase results instead of seeking structure. You are memorizing outcomes instead of understanding causes. That approach produces confusion, frustration, and the false impression that physics is inherently chaotic. Once the unifying perspective is internalized, the mental landscape transforms. Mechanics is no longer a separate world from optics. Waves are no longer distinct from quantum behavior. Electromagnetism is not a foreign system unrelated to motion. Every equation, every trajectory, every phenomenon is a ripple of the same principle applied in context. The fragmentation disappears, confusion collapses, patterns emerge. What once appeared as disconnected rules now appears as inevitable consequences. The power of this perspective extends beyond simplification. It also deepens intuition. Human intuition, built on everyday experience, is local. Push something, it moves. Drop something, it falls. That intuition works for immediate perception but fails for deeper reality. The stationary action principle demands holistic thinking. It treats entire trajectories as coherent entities integrating energy and motion over time. The focus shifts from instantaneous snapshots to complete histories. It forces you to think globally, to see beyond appearances, to recognize inevitability. This holistic view also explains why nature often appears elegant. Planetary orbits, oscillating springs, light bending through media. These are not random phenomena. They are expressions of a principle that operates consistently across scales. The elegance of motion is not aesthetic or coincidental. It is the natural outcome of stationary action selecting trajectories that balance energy efficiently over time. Complexity arises from this selection, not from arbitrary rules imposed independently. Consider teaching methods again. By dividing topics artificially, the education system creates the illusion of complexity. Chapters, headings, and isolated formulas encourage rote memorization and suppress structural thinking. Students become adept at solving problems mechanically but remain blind to the deeper unity. The result is a mind trained to react, not to understand. The result is a world where physics is hard, is accepted as truth. But physics is not hard. Fragmentation is. Confusion is. Misunderstanding is. Recognizing the unity of physics also changes the way new phenomena are approached. Instead of treating anomalies as exceptions, they are interpreted as new expressions of the same underlying rule. A new system, a new interaction, a new particle, the same structural lens applies. The stationary action principle generalizes. The unifying idea does not break under expansion. It adapts. It remains reliable, consistent, and predictive. Once seen, this unity is impossible to ignore. Every law becomes a consequence, every equation becomes inevitable. Every trajectory, every field, every particle path becomes understandable through the same organizing principle. You stop memorizing separate rules. You begin to internalize a single coherent logic that generates all laws. This is not convenience. This is clarity. This is power. Physics is no longer a fragmented collection of chapters. It is one continuous architecture expressed in many forms. Once that is recognized, the surface complexity collapses. Confusion disappears. The universe becomes readable, predictable, and astonishingly elegant. Every phenomenon, from falling objects to quantum fluctuations, is no longer mysterious. It is a direct outcome of one principle applied relentlessly across space, time, and energy. Stop asking what force causes this. Stop treating each event as if it exists in isolation. That mindset is the reason physics has always felt confusing, overwhelming, and fragmented. Forces are descriptive, they summarize, they explain appearances, but they are not fundamental. At the deepest level, the universe does not act by applying pushes and pulls as separate events. It operates according to a principle of structure, consistency, and optimization, the principle of stationary action. Understanding this changes everything. Begin with a simple reframing. Instead of asking, what accelerates this object, ask, what path minimizes the action? That single question reorganizes understanding. It replaces scattered roles with one coherent framework. The trajectory of every system, from a falling apple to the motion of planets, from oscillating springs to propagating light, can be derived by evaluating which path makes the action stationary. Forces, accelerations, and velocities emerge as consequences, not prerequisites. This is a radical shift. It turns reactive thinking into proactive reasoning. This approach forces you to look at systems globally rather than locally. Traditional thinking isolates a moment in time, measures forces acting at that instant, and predicts the next position. That works for many calculations but misses the deeper story. The stationary action principle evaluates entire histories. It asks, over the complete interval between two states, which path balances energy and time most efficiently. That path is not selected arbitrarily. It is selected deterministically by the underlying structure of the system. Small deviations from that path either increase or fail to maintain stationary action. The universe does not meander. It selects. Consider light as an example. It does not simply bend because of a medium. It follows a path where the travel time is stationary. In uniform media, that reduces to a straight line. In varying media, the path curves exactly as needed. Reflection, refraction, lensing. All are outcomes of a single principle applied in different contexts. The stationary action principle explains them all without invoking separate rules for each phenomenon. Once this is understood, why does light bend? stops being a question about cause and becomes a question about optimization across time and energy. Mechanics behaves in the same way. A projectile follows a parabolic arc, not because gravity pushes it into shape, but because that trajectory is the one that makes the action stationary under the influence of kinetic and potential energies. A pendulum swings with predictable periodicity because its motion satisfies stationary action continuously over time. Oscillation, orbit, fall, all are optimized paths rather than reactions to individual forces at isolated moments. The universe does not improvise. It evaluates. It filters. It selects. This perspective reframes problem-solving entirely. When faced with a new physical scenario, the first step is no longer to look for a formula or assign forces. The first step is to define the system. Energy structure, kinetic and potential contributions, constraints, boundary conditions, and then ask, which trajectory makes the action stationary? Once the action is properly defined, the resulting equations of motion appear naturally. This transforms physics from a set of memorized rules into a process of reasoning from first principles. Derivation replaces rote calculation. Insight replaces mimicry. Even quantum mechanics, which appears to defy classical intuition, obeys the same rule. In the path integral formulation, a particle does not have a single classical trajectory. Instead, it explores all possible paths. But the stationary action path dominates because neighboring paths interfere constructively, while wildly divergent paths cancel out. The classical path emerges as a natural outcome in the appropriate limit. What seems like randomness is actually the macroscopic consequence of coherent optimization at the underlying level. The rule remains intact. It adapts. It governs across scales. Adopting this mindset exposes a harsh truth. Most of what feels confusing in physics is self-inflicted. Learning formulas by chapter, memorizing force laws, treating phenomena as disconnected, these habits create the illusion of complexity. The universe is not inherently complicated. Fragmented thinking is. Once the lens of stationary action is applied, the apparent chaos collapses into a unified framework. Equations, trajectories, fields, and probabilities become inevitable consequences of a single principle. This shift also cultivates intuition that goes beyond memorization. Human intuition, shaped by immediate experience, is local and reactive. Push something, it moves. Let go, it falls. That intuition works for day-to-day perception but fails at fundamental scales. The stationary action perspective forces global thinking. It treats entire histories as coherent entities integrating energy and motion across time. Systems are understood in terms of optimization, not moment-to-moment reaction. Understanding emerges not by memorizing outcomes but by reasoning from structure. Once this perspective is internalized, the way problems are approached changes. Instead of memorizing equations or consulting charts, you identify the energies, constraints, and boundaries of the system. You apply the principle of stationary action. The resulting behavior becomes derivable, predictable, and inevitable. Motion, oscillation, light propagation, planetary orbits all can be understood as natural outcomes. This transforms learning from a mechanical exercise into a process of understanding the architecture of reality itself. Adopting the question, what path minimizes action, is a small shift in wording, but it is a massive shift in approach. It rewires perception, forces structural thinking, and replaces surface memorization with deep comprehension. Every system becomes a case study in optimization. Every motion, field, and interaction is read as a consequence, not an arbitrary event. Confusion recedes. Complexity simplifies. Physics ceases to feel like a random assortment of rules and starts to feel inevitable, elegant, and coherent. Once this mindset takes hold, understanding becomes active rather than reactive. It encourages exploration, derivation, and recognition of patterns. The focus moves from isolated calculations to the logic underlying the universe. And once that logic is grasped, every phenomenon, from the simplest to the most complex, becomes a window into the same structural truth. The truth most people never admit is that understanding physics requires effort, real effort. Most minds take the easy route, memorizing formulas, following recipes, repeating steps without questioning why they work. That approach produces temporary results. Exams can be passed, problems can be solved mechanically, but it leaves the deeper structure invisible. It leaves the mind fragmented. It leaves confusion as the default state. The universe does not reward shortcuts. It does not cater to convenience. The stationary action principle, which underlies almost all of physics, is relentless. It does not bend for human laziness. It does not simplify itself for memorization. To truly grasp it requires persistence, patience, and willingness to see beyond appearances. That is why so many never get it. The principle is simple, yes, one idea, but simplicity does not equate to triviality. It demands rigor. It demands engagement. Effort is required because the principle operates globally. Physics is not just about a single instant. It is about entire histories. Small variations, integrated over time, determine whether a path is realized or discarded. Instant-by-instant thinking cannot penetrate this structure. To understand the underlying logic, the mind must learn to think across intervals, to integrate energy and motion as continuous flows rather than disconnected events. That is uncomfortable for intuition built on local experience. It is unfamiliar. It is demanding. Most people avoid this discomfort. They cling to memorized rules and chapter divisions. They learn formulas as if they were magic incantations. They solve problems step by step mechanically, without questioning where those steps originate. That approach creates the illusion of competence, but it is fragile. It collapses in the face of new systems, new Lagrangians, or slightly different constraints. Without understanding the foundation, every anomaly feels insurmountable. Complexity seems overwhelming because the underlying unity is ignored. Here is the uncomfortable truth: if you avoid foundational principles, you will always feel physics is hard. It is not physics that is inherently complicated. It is the fragmentation of your mind that makes it so. The universe itself is efficient, consistent, and coherent. The difficulty arises from approaching it as if each phenomenon were isolated, as if every law were independent. That mindset breeds fear, hesitation, and confusion. The stationary action principle exposes this illusion. It strips away artificial divisions and shows the inevitability beneath. Effort pays off, because once the unifying principle is internalized, the landscape changes completely. Mechanics is no longer disconnected from electromagnetism. Optics is no longer separate from motion. Quantum behavior no longer seems alien. All of these systems can be viewed as manifestations of the same underlying rule, the trajectory that satisfies stationary action. Different appearances, same backbone. The principle scales across energy, time, and space. It is the common thread linking centuries of discoveries, from Newton to Maxwell to quantum theorists. The harshness of the effort lies not only in learning the mathematics but in reshaping the mind. It is easy to perform calculations mechanically, but much harder to rewire intuition. You must learn to see systems as holistic, interconnected entities. You must resist the temptation to think locally. You must integrate energy, motion, and constraints across entire paths, not just isolated moments. That mental discipline is what separates shallow understanding from true comprehension. The path of effort is also deeply rewarding. Once the principle is understood, it begins to illuminate phenomena that once seemed mysterious. Orbits, oscillations, waves, light bending, and quantum behavior no longer appear as disconnected miracles. They are outcomes of the same principle applied across different contexts. Confusion collapses into clarity. Equations become not arbitrary symbols, but inevitable consequences. Complexity transforms into structure. The universe begins to feel readable, predictable, and astonishingly elegant. Another uncomfortable realization is that the universe does not help memorization. It provides no shortcuts. Every derivation, every insight, every trajectory emerges from the structure itself. This is why rote learning fails at the foundational level. Understanding cannot be outsourced to formulas. Understanding requires engaging with the principle actively, struggling with derivations, wrestling with concepts, and reasoning through energy and time. That is effort. That is the requirement for comprehension. The consequence of avoiding this effort is long-term fragility. Students or learners who rely on memorization can solve problems they have seen before, but they fail when conditions change slightly. They struggle to generalize, to adapt, to recognize patterns across systems. The stationary action principle, once grasped, equips the mind to see connections immediately. It makes problem-solving structural rather than reactive, but reaching that point requires committing to effort beyond convenience. Finally, the effort is about clarity. The effort is about unifying perception. The effort is about transforming physics from a list of chapters and equations into a single coherent architecture. Once the effort is invested, memorization becomes irrelevant. Problems no longer intimidate. Complexity becomes natural. The same principle explains motion, waves, light, and quantum phenomena. The mind begins to see inevitability, not chaos. Effort is not optional. It is the bridge between confusion and understanding. It is the price of seeing the underlying unity of the universe. Without it, physics remains fragmented, intimidating, and shallow. With it, clarity emerges, insight emerges, understanding emerges, and once that happens, every equation, every path, every trajectory becomes a natural outcome of one relentless principle applied across space, time, and energy. Effort is uncomfortable. Effort is demanding. Effort is non-negotiable. But it is also transformative. It turns memorization into comprehension, rules into inevitabilities, and complexity into elegance. The universe rewards those willing to engage deeply. Those unwilling to invest will remain trapped in confusion, misperceiving fragmentation as intrinsic difficulty. The choice is yours: struggle and understand, or avoid and remain blind to the structure that governs everything. It's time to stop pretending that understanding physics is about memorizing formulas, following instructions, or repeating steps mechanically. That approach produces temporary results, but it leaves your mind fragmented. It leaves confusion in place of clarity. It leaves you dependent on instructions instead of reasoning from principle. The truth is harsh. If you want to truly understand the universe, you have to confront reality as it is, not as it appears in textbooks or in simplified classroom examples. The stationary action principle is the key, and it is non-negotiable. Either you engage with it, or you remain trapped in superficiality. This principle is not abstract. It is not theoretical fluff. It is the framework from which all motion, all trajectories, all interactions emerge. The paths of planets, the oscillation of springs, the bending of light, the propagation of fields, and the behavior of particles at quantum scales, they are not random or isolated. They are selected by one single rule. The path taken makes the action stationary. Once you internalize this, the universe begins to make sense in a way that rote memorization never could. Your mind has been trained to see physics as fragmented, to separate motion from fields, classical from quantum, optics from mechanics. That training produces confusion. It produces the feeling that physics is overwhelmingly complex, as if reality were a chaotic assortment of unrelated rules. The brutal truth is that the complexity is mostly in perception, not in nature. Once the unifying principle of stationary action is understood, the apparent chaos collapses into coherence. Different systems, different scales, different phenomena, all are expressions of one structural rule. This is the mindset that transforms a student into a thinker. Stop asking, which formula should I use? Stop asking, what is the force acting here? Start asking, what is the energy of this system? And which path through time satisfies the stationary action condition? These questions shift thinking from reactive problem-solving to proactive derivation. Every trajectory, every oscillation, every motion becomes a consequence, not a mystery. Insight replaces memorization. Understanding replaces mimicry. The harshness of this realization cannot be ignored. It forces you to confront the limitations of intuition. Your everyday experiences, pushing objects, throwing balls, dropping things, trained your mind to perceive forces locally. That intuition works at human scales but fails at fundamental scales. The stationary action principle requires global thinking. It treats entire histories as coherent entities, integrating kinetic and potential energy across time. It forces the mind to reason across intervals, not just at isolated moments. That is uncomfortable because it is unfamiliar. It is demanding because it is precise. Yet, once that discomfort is embraced, clarity emerges. The seeming divisions between classical mechanics, electromagnetism, optics, and quantum mechanics disappear. Orbits, waves, light propagation, and particle paths are no longer separate mysteries. They are all the result of the same principle applied to different energy structures. The diversity of phenomena is a surface effect. The underlying rule is constant. That realization transforms confusion into inevitability. Equations cease to be arbitrary. Motion ceases to be surprising. Nature ceases to feel chaotic. This principle also teaches a brutal lesson about effort. Understanding physics is not about convenience. It is not about shortcuts. You cannot memorize your way to comprehension. You must engage actively, reason through the derivations, wrestle with the concept of action, and see how trajectories emerge from optimization. The universe does not simplify itself for you. It does not accommodate laziness. Every insight, every trajectory, every law arises from the structure itself. To see it clearly, you must invest mental energy beyond repetition. Applying this mindset changes everything about learning and problem solving. You no longer approach phenomena as isolated puzzles requiring tricks. You approach them as systems with energy, constraints, and boundary conditions. The question is always the same. Which path makes the action stationary? Once that path is identified, the resulting behavior emerges naturally. Motion, waves, oscillations, and even quantum effects become derivable rather than arbitrary. Complexity becomes structure. Mystery becomes inevitability. The impact of this perspective extends beyond understanding physics. It cultivates a way of thinking that is structural, coherent, and principled. Instead of reacting to problems in fragments, the mind learns to see the underlying pattern. The mind stops memorizing results and starts reasoning. It shifts from short-term imitation to long-term comprehension. It begins to recognize inevitability, predictability, and unity in systems that once appeared chaotic. And here is the final, inescapable truth: knowledge without application is meaningless. Understanding the stationary action principle is not enough if it does not reshape your approach. You must actively apply it to every problem, every system, every trajectory you encounter. That principle is powerful, but only if it guides your reasoning. Passive recognition will not produce mastery. Only engagement, analysis, and persistent application will. So this is the challenge. Stop treating physics as a collection of disconnected facts. Stop memorizing formulas without seeing the logic that generates them. Stop accepting confusion as inevitable. Commit to seeing the unity beneath the apparent diversity. Commit to thinking globally, reasoning structurally, and deriving outcomes from principle rather than relying on instruction. The stationary action principle is relentless, consistent, and unforgiving, and so is reality itself. The choice is yours. You can remain in superficiality, trapped in fragmentation, memorizing without comprehension, reacting without insight. Or you can rise. You can embrace the principle that explains almost all of physics. You can restructure your mind, unify your understanding, and see the inevitability behind motion, fields, waves, and quantum behavior. That one idea is waiting. It will not come gently. It demands focus, engagement, and courage. But once you take it seriously, your understanding of the universe will never be the same. The universe does not wait for convenience. It does not simplify from memorization. It rewards rigor, persistence, and structural thinking. The stationary action principle is the lens. It is the framework. It is the truth that unifies everything. Apply it. Internalize it. Let it reshape the way you see the world. The choice is yours, and the consequences are immediate. Either clarity and coherence, or continued confusion and fragmentation. The question is simple: will you act, or will you remain a passive observer in a universe that operates on principles far deeper than your current perception? The path forward is clear. Engage, reason, derive, and understand. Embrace the one idea that explains almost all of physics. Because once you do, everything changes.